Welcome to Binding Blocks. The nuclear chart that we see in front of us consists of more than 3,000 piles, each representing one nucleus. But is it finished, or are there more nuclei to discover? Since the turn of the millennium, hundreds of new isotopes have been found. Most of those reside either on the neutron-rich or the neutron-deficient side of the nuclear chart. Some of them, however, constitute new chemical elements. The heaviest element that is naturally abundant on Earth is uranium, with 92 protons. But as of today, scientists have discovered elements with up to 118 protons. Of those, the ones that have more than 103 protons are referred to as super heavy elements, and they have all been created in laboratories by taking lighter atoms and colliding them into heavier ones. For element 118, the scientists used a beam of calcium and let it impinge on a target of californium. Calcium has 20 protons, whereas californium has 98. If we sum it up, it makes element 118. This element has recently been named Oganesson, after the scientist Oganesson, who first discovered this element. The superheavy elements are radioactive and decay primarily via alpha decay, the yellow ones, and spontaneous fission, the green ones. If we look at the lifetimes for the very heaviest ones, they are 1 second or less. Whereas if we go to somewhat lighter elements, they can increase to minutes or even hours. Considering this trend, if we would go to elements that are heavier than element 118, the lifetimes are expected to get shorter and shorter. And this is because of the increasing electrostatic repulsion between the positively charged protons. Nonetheless, I believe that in the next couple of years, we will be able to extend the nuclear chart with more super heavy elements, albeit with very short lifetimes that make them unfit for technological uses. However, there are predictions that if we would manage to put more neutrons into the isotopes that we have discovered, this would make them more long-lived. There are long-standing predictions that just to the neutron-rich side of the isotopes that we have seen, there is an island of stability. To find this island is my dream.